Hypotheses about how dinosaurs would have acted in life can be quite a diverse and heavily debated upon field. And through all of this, there are some that are better or less supported by both current and future evidence that turns up or is presented. No matter how many rigorous and detailed studies may be published from the most reputable of researchers and scientists, sometimes, among them, some quite unusual ones will turn up that have no real prior backing, aside from being a pet hypothesis by the author, seen most notoriously in the Paleo community with people like David Peters, well known for often outlandish, flamboyant, and sometimes incredibly unusual ideas and reconstructions, which are always a treat to pick apart for their absurdity. One of the wackiest though that I've come across as of late is one by a man known as Garnet Fraser, a GP in the Department of Medicine at the University of British Columbia, who has some, let's just say, mixed reviews regarding the way he goes about things, already a big red flag for what's to come. Regardless, he took up the challenge of writing a short paleontology paper, and given that he's involved in medicine and not ecology and especially paleontology, things don't bode well. The paper's central theme is on dromaeosaurs, the raptors, and how apparently the predation, or as he puts it as parasitism, is what led to so many of the elaborate defensive and or display structures of numerous herbivorous dinosaur groups coming about, from ceratopsian neck frills, stegosaur plates and sauropods' dermal spines, so it's already off to a great start. The paper, to give it credit, does support dromaeosaurs using their sickle claws to grapple with prey and puncturing animals rather than slashing and tearing with them, though instead of going for a restraint muzzle which is more commonly accepted, and also well supported by their morphology and their relatives today, which incorporates their techniques to capture prey. Instead, Fraser uses this bit of information to then tie it into his own idea of parasitism, a common theme which will be evident throughout, and that these claws were specifically evolved to hang off of larger dinosaurs to feed off of them. From this, he notes that golden eagles have been documented attacking reindeer calves and pronghorn to feed on them, using their claws to rise on their backs, with periods of rising being separated by disengagements and then being followed by ongoing attacks. Also bring up vampire bats and vampire finches, though these cases are very niche, with both animals being vastly different both in morphology and size to dromaeosaurs, which would not be able to guess away with similar behaviours on the animals Fraser theorises they would have targeted, considering vampire bats and finches are both tiny animals that can easily flit away from any discomforted animal, and in the vampire finch cases, the animals they target, like boobies, hardly even react. This doesn't however suggest heavy parasitism on larger animals though, more so that these animals, which are generalist in both their hunting and dietary habits, will incorporate different tactics to feeding on and hunting varying types of prey. Eagles rising the back of deer is not them being parasites, they are instead targeting animals which are either so weak they can hardly fight back or run away, as in the case of pronghorn, or are small enough to be prey themselves. Living parasites don't outright kill their hosts, since they need them alive for sustenance. An eagle latching onto a deer, dealing damage, and then continually circling back to finish them off does not fit such criteria, considering they have the end goal of finishing them off to then feed on their corpse, rather than keeping them alive so that they can remain attached. Fraser also notes both the diet and behaviour of wolverines, also comparing their latching onto the backs of their prey, like moose and deer, as a further piece of evidence for his hypothesis, and that because bone fragments in their scats mainly show smaller animals and birds, given they can be swallowed whole or in big sections, he suggests that because this doesn't show the primary food source of larger game in the winter months, that therefore indicates that scat remains are not enough to determine a carnivore's typical diet. Extrapolating from this, he notes that because Microraptor of all animals, one much smaller, and with different ecology than wolverines mind you, of smaller avian bones in them, that this doesn't necessarily indicate their main diet, since eating the soft tissues of larger dinosaurs wouldn't show in the same ways. Their elongated snouts are also assumed to help them gain access to flesh, amongst the spikes, scutes, and plates of larger dinosaurs, noting that extant phylogenetic bracketing isn't very useful in explaining all of these bizarre structures, though given how general of a trait, having a longer snout to reach deeper into carcasses is, this being the primary catalyst for their development in dromaeosaurs, is very strange for something so niche. Regarding their ability to both engage and disengage from being latched onto a target, Fraser looks to cookie cutter sharks, yes, those little dudes for comparison, and that they can quickly swim away in response to thrashing behaviours as they forage, using their bioluminescence and nocturnal habits to do so. Even more wacky is that from this dismounting, Fraser theorises that said dismounts are also the reason for wing development and flight in these animals, and that every incremental stage of wing and feather development would have over time reduced the risk of injury from said jumps off of much larger animals, which is wrong for many reasons. Feathers do indeed have the beneficial side effects through their fluff of being insulative from falls, most well known in wood duck chicks, who will jump off of cliff faces when they leave their nest. though this being a catalyst for flights that would lead to avians is quite erroneous, given that the groups that led to aves, modern birds, had already split off in the Jurassic, and the evolutionary relationships they share to dromaeosaurs is more in the way of being a cousin lineage rather than one of direct ancestry. A constant of this paper is also bringing up animals that have more lithe proportions that seem to imply riding behaviour, though they can be easily explained in other, more common ways that don't involve twisting them to fit a preconceived idea. He notes that animals like Anchiornis, due to having long legs, meant that instead of being arboreal, seemed to be better suited to living a grounded lifestyle, in spite of the heavily feathered hind limbs and, well, other animals that are known to look quite gangly, that are much more at home in the trees than on the ground. The more slender jaws of these smaller avians are suggested to have improved access to soft tissues in narrow gaps between scales and osteoderms, while larger dromaeosaurs could chew through thickened layers of skin, occupying a different parasitic niche. Another trait dromaeosaurs have that is also inferred and brought up to be an adaptation to said quote-unquote parasitic behaviour is how their pubis is positioned, with it being retroverses and or opusly pubic that Fraser suggests allow them to facilitate rising behaviour on prey. Instead of parasitism, said observation is an interesting one, since dromaeosaurs grappling prey to bring them down is an under-discussed method of restraining their prey, alongside the previously mentioned raptor prey restraint. Alongside using their arms for balancing on top of their prey to kill them, their ability to grapple with them is also something that they did indeed do, since numerous stress fractures have been noted on animals like Deinonychus on their arms for multiple individuals, meaning that they did use them extensively, with animals like Deinonychus indeed being known to feed on larger animals like Tenontosaurus, which were not as big in comparison as most think, though still formidable adversaries. Comparisons in this case have been made between raptors and felids in this regard, with most researchers agreeing on ambushing being most likely for them given their anatomy when compared to other theropods, with animals like tyrannosaurs and troodontids being more cursorial. The most wacky part of the publication comes on how the supposed host of these raptors defended themselves against these apparently very persistent and formidable foes. I'll go over the problems with what I'll be stating from the paper after I go through the list presented, and to cover why each of them are very unusual and highly unlikely, plus what is blatantly inaccurate or neglected. Stegosaur plates are quite the unusual structures, and them, alongside other groups of herbivorous dinosaurs, are theorised in this case to have developed these extravagant structures to defend against raptor latchings. Said plates are known to not be too solid, being mainly composed of spongy, trabecular bone with an outer and thinner layer of keratin, and in this case are thought to hinder dromaeosaurs in terms of them being able to jump up on them and latching on. It also states that nature seldom selects for such structures for display alone, and that it is very uncommon for both sexes to go to such extreme lengths, since it is usually one or the other, usually the males. It goes on to suggest rather wildly that the temporal association between the early evolution of dromaeosaurs in the Jurassic and the enlargement of stegosaur plates over the latter half of the period was more than coincidental, and that improved capabilities through dorsal attacks led to the extinction of stegosaurs near the end of the Jurassic, a flawed conclusion for many reasons, as will be covered. Ceratopsian frills are also thought to have developed in a similar way to deal with them, with their great length in some genera potentially allowing them to protect their necks, and to either stab or flick the raptors off, also mentioning the lack of sexual dimorphism, and the scales of hadrosaurs being among the oddest of points. This is from the presence of tubercles, which make the skin more resistant to puncturing and tearing, likely from predation by large carnivores, was an evolutionary attempt at a deterrent against the nibblings of raptors. Also bringing up the unicorn or otherwise phallic-looking Chindalsaurus's crest as another example, which is out of date now that we know the full extent of the crest. The crests of animals like Parasaurolophus and other lambeosaurs are also thought of as being even more effective weapons in this case, being able to swing them around like a club to bat them off. The midline dorsal scales of some taxa are also thought by Fraser to have a serrated edge that's when a hadrosaur bucks and tries to remove a riding dromaeosaur could damage them in the process. Pachycephalosaurs are also brought up as animals that responded to this threat, but given their size, dromaeosaurs being parasites is not only redundant, but unnecessary since just straight up killing them in an encounter would be more beneficial in terms of resources gained, given the size of many animals in the group. Even sauropods are thought to have developed adaptations to defend against raptors, with the study bringing up the unusual Margosaurus as an example, noting their admittedly very unusual branching neural spines, which are interpreted by Fraser as being evident devices to stab at attacking animals, although it's mainly thought now that these were covered in skin and muscle, though the point remains that this is rather unusual. Other sauropods with their osteoderms and spines are also thought to be adaptations for said purpose, and even Spinosaurus of all animals is brought up, something funny given how much of a mess the discussion still is today around them. Their parasitic feeding has also been brought up as to explain the osteomyelitis, the inflammation and bone swelling seen in the bones of animals like ceratopsians and hadrosaurs, which have otherwise been explained as either trauma caused by the stepping on tails by conspecific animals in a herd, or by falls, things which make a whole lot more sense given how huge these animals are, and how much of an effort it would be for even a small dromaeosaur to get onto them and survive. To conclude all of this, all of these results are really out there, and do require a lot of reaching. To start, regarding stegosaurs, their place and osteodome diversity was very diverse, with animals like Miragaia and Kentrosaurus being quite different in how they appear, also living around the same time as Stegosaurus, so the group's wholesale conversion to larger plates to fend off dromaeosaurs is pretty flawed in this way. Their function is also something to be skeptical about, since it is very often that researchers, especially on extinct animals, try too hard to find quote-unquote functional explanations when confronted with said strange structures, when they are more than likely flamboyant because they've evolved under selection for, well, being flamboyant. Testing the other possible functions for something other than display is worthwhile, and what's been found is that they may well have been multi-purposed, as are many structures in nature. A thermoregulatory purpose has also been suggested in the past, though both variation plates, across taxa, and other composition has rendered this less plausible, although it hasn't completely gone away. Papers have reported from CT scan data from Stegosaurus plates and alligatoroid osteoderms, with them showing that there were internal pipes that formed a branching structure that extends along each plate's base, which could well have worked as some kind of vascular distributary system. Some work, which includes thermal imaging, has shown that crocodilians do use their scutes to help in transferring heat to warm themselves, and so it seems as if their plates were indeed multifunctional structures, most likely with the main display origin with the thermoregulatory bonus, in many cases found to be better at actually shedding heat than retaining it. The apparent lack of sexual selection in both the stegosaur plates and ceratopsian horns and frills which the paper mentions is also erroneous, since stegosaur plates may well have been sexually dimorphic if the case for animals like Hesperosaurus is considered valid, although there's still a lot of discussion to be had regarding all of that. Indeed, there is no clear sexual dimorphism in these animals that the paper brings up, although something both it and other papers miss is that mutual sexual dimorphism is also an explanation, and something that is seen today in living archosaurs, where both male and female animals are ornamented to both attract and select mates, alongside in the broader subgroup, Ornithodira, which is defined as being the last common ancestor of both dinosaurs and pterosaurs and all of their descendants. Determining sexual dimorphism is made all the more difficult by the low sample sizes many fossils provide, and even in the cases where scientists can be confident that sexual dimorphism is absent, the possible existence of mutual sexual selection in these taxa means some form of selection is potentially still at play. Birds like crested auklets, which are monogamous with biparental care, both bear distinct feather plumes on their heads which both sexes prefer, and both are more dominant, as well as in black swans and many other birds which have killed feathers. Dinosaur ornamentation in many groups, often than not, have no similar modern correlates, so said display features, like in these animals, does not preclude them from using them for similar purposes, even if they are quite different. Stegosaurs going extinct at the hands of dromaeosaur predation is one of the most absurd aspects of the whole paper, considering that most extinctions of animal groups occur through environmental or climatic changes, with overpredation generally leading to extinctions in either very stressed populations or ones that are naive to the new dangers of invasive animals. Their tiny size in comparison, which will be discussed further, is one of the most striking blows against this. Along with that, there may well be a correlation to be found when it comes to their decline and extinction. Some remains, either from trackways or from physical fossils, have been occasionally referred to be cases of them as a group surviving until the very end of the Cretaceous, although a lot of these finds have either been found to have been misinterpreted remains of other animals, or inconclusive at best for the moment. Stegosaur diversity may well have been impacted as a part of the Jurassic-Cretaceous transition, by which angiosperms or flowering plants became more dominant, causing a faunal turnover where newer groups of herbivores evolved. Unlike all the other herbivorous groups, they show significant negative correlation with flowering plants, and a significant positive one with non-flowering cycadophytes, which coupled with ankylosal radiation around this time. Animals that are often compared to them, how generally similar they are both in body plan and niche, may well have filled in the gaps left by the stegosaurs, though this requires further investigation. The crests of hadrosaurs, also like ceratopsians and stegosaurs, were very likely to have played a large part, not only in display, but in communication, with some being found to have chambers that would have allowed for more resonant calls, which would have allowed their calls and sounds to travel further, alongside CT scans revealing a delicate inner ear that would have allowed them to detect low frequency sounds. The tubercles of hadrosaurs, described by Fraser, which would indeed have made the skin more resistant to puncturing and tearing, sure sounds like such structures would be more well suited to a more common and real threat, like, I don't know, the several large tyrannosaurs that lived in the same areas as them, and were the true dominant predators? Oh no, it's more likely that it's from small eagle-sized animals, somehow managing to clamber up onto elephant-sized or even larger animals, all while risking a crushing death. Therein lies the biggest problem with the paper and the idea of dromaeosaurs being these specialised parasitic animals that influence so many dinosaur groups over such an extent of time on a global scale. For one, dromaeosaurs apparently very specialised anatomy for such roles, when looked at, is really not all that derived or too different from similar animals, and the case could also be made for animals like eagles and broadly pterosaurs for also being facultative parasites, animals that would in fact be a lot better equipped for the role given their powered flight to allow them to both easily reach the backs of larger animals and to make a quick escape if they are at risk. Outside vampire finches and a handful of other small birds, this kind of behaviour and lifestyle, well, just isn't seen. Extent comparison with living animals is a very good way to test and compare paleo hypotheses like this one presented, and so such things can't be ignored, like the fact that tetrapods don't match many of the parasitism standards for many reasons, like their size and metabolism in favour of other, more sensible ideas that can be more easily backed up and with less cherry-picking of data. Dromaeosaurs in most instances are commonly large eagle through to wolf-sized animals, far larger than all of the animals he talks about in the paper, and so them clambering up animals the size of elephants would not only be more noticeable, but far riskier for them given that they can't effectively get away if things don't go well, given they are unable to either quickly camouflage, swim, or fly away. The noting of eagles and wolverines as attaching to the backs of prey to attack is indeed true, but this does not classify them as parasites through the given criteria to be one, and Fraser appears to have conflated predator struggles over long periods with facultative parasitism, e.g. not relying on the host for their life cycle. Parasitism is inherently a non-mutual symbiotic relationship between species, where, unlike predators, parasites don't set out to kill their host, and are also very much smaller, being able to live on their host for extended periods. Dromaeosaurs grappling with their prey is therefore quite weird to bring up as something parasitic, any more so than what happens with wolverines and eagles, alongside other animals like lions, which will often hang on to their prey to grapple with them for extended periods before eventually finishing them off. By this logic, a huge amount of living predators could be considered as parasitic, but under the typical and reasoned definition, they do not by any means. Saying their curved claws and cursorial leg proportions meant that they were specialised for a parasitic lifestyle could be said for almost any small avian or mammalian predator, and in these animals, cases of parasitism is very rare and is constrained by varying factors. To face such an apparently widespread and uniquely effective parasite, it would be assumed that many of these different groups would converge, at least in some way, to some sort of similar defence mechanism, but that just isn't the case. The paper seems to take after dromaeosaurs being such dominant animals compared with others in their ecosystem, which were up there as some of the top predators/influencers, seen very infamously in certain pieces of media as unstoppable and super-brained animals. Though such overemphasis on their prowess is evidently not realistic given how such attacks would actually go, and a lot of it comes down to dramatically underestimating other dinosaurs in their environment. Varieties of morphological features developing to deal with predators also reflects the variety of their predators, and at least from what I know, there is, nor has there been, one group of parasites or predators which has apparently affected this much of their prey, and their evolution in such a dominant way, over such a long period of time, in this case around 75 to 80 million years, and it also seems that the paper is trying to fit all of that in to make all of the details fit in with their model, with a hefty amount of bias thrown in there to try and favour it over other explanations. Their presence alone doesn't explain all of these structures, and actual explanations, that being for defence against bigger, more substantial threats or for display, are both more well substantiated and have correlates today, something which the parasitic dromaeosaur lifestyle just doesn't have, demonstrating an apparent lack of understanding for how all of these structures came about and what influences them. Some attempts to find an anatomical correlate between modern analogues and dromaeosaurids, their relationship with the lack and presence of elaborate structures and other such prerequisites would help in making said ideas testable for other scientists, and the paper overall could and should be seen as a mere suggestion, an outlandish one, but nothing more. Given that David Peters, mentioned earlier, has also advocated for very similar ideas amongst alvarezsaurs, animals in many ways even more poorly suited to the task than dromaeosaurs, it's safe to say that such an idea is a very wacky one, though for Peters, it's a drop in the bucket for how many wild things he says, which could well be a video all unto itself, but that's for another day. All in all, I thank you for watching this video on these animals and that you may have learned something new. If you would like to see more from this channel, be sure to subscribe if you haven't already. And with that, I'll see you next time, whenever that may be.